In this video, we'll have a look at lipids as we start to work our way through the organic compounds. So lipids are a very important group, and let's define what they are. So we're looking at lipids. It's a group of nonpolar hydrophobic molecules, and they're largely contain carbon and hydrogen. There's some other things, but those are really the two big things we see. Now we can subdivide them, or they do also include, I should say, the fats and the oils. Now let's talk about fatty acids. So they fall under the group of lipids, but fatty acids have some unique characteristics. They're lipid monomers, and they are between 4 and up to about 20 carbon atoms. Now they may or may not have bonds. So some of these fatty acids don't have any, I shouldn't say bonds, have no double bonds. Some of them have one, or some of them have more than one double bonds. And we're going to have a look at that as we look at how they're structured in these hydrocarbon chains. So let's have a look at some of these. Now here's an example. This is one of these saturated fatty acids. So you can see that the structure is a series, I'm going to zoom in here, a series of carbons that are attached. And you can see that really the sides are attached onto hydrogen. So we have a carbon backbone with hydrogen sticking off from there. Now at one end we have a carboxyl group, which is the OHC double bonded to an O. So that's your basic structure when we're looking at fatty acids. Now, when we talk about fatty acids, sometimes we'll hear about saturated fatty acids. And what are the characteristics of saturated fatty acids? Is that they're solid at room temperature. And as I look down this carbon backbone, I don't see any double bonds whatsoever. So that tells me there's no double bonds between the carbon atoms. And that's where the name comes from, because we're saying it's saturated. They're already saturated with hydrogen atoms, so they have the maximum number of hydrogen. So one of the groups is saturated fatty acids, and the characteristics: solid at room temperature, no double bonds in the carbon backbone chain here. As I said, there's a number of them, and one of them would be palmaric acid. You don't have to remember the structure of these in great detail, but you should know the generalities of what they are. Now, let's look at the group which we can call monounsaturated. So this suggests mono for one, and it's telling us that, remember the last one was saturated, that this one is unsaturated. So it's telling us that there's going to be one double bond somewhere in there, because not all the carbons are saturated. Now when we're looking at monosaturated fatty acids, we're really generally talking about things that tend to be liquid at room temperature, and they have one double bond between the carbon atoms. So if we go back to the previous one, you can see how it's all single bonds in this chain of carbon atoms. Here in the monounsaturated, it's almost all single bonds, but we do have one place where we do have a double bond. So this is one of the examples of a monounsaturated fatty acid, and it's oleic acid. Now, what if we have more than one double bond? That gets us into the category of the polyunsaturated fatty acids. These ones are liquid at room temperature, so they have two or more double bonds between the carbon atoms in the carbon chain. And we can see here, once again, we have our functional group, our carboxyl at the end here. And then we have our chain, and up to this point, they are all, let's zoom in, they're all single bonds. And then all of a sudden we have a double bond here, so that tells us it's unsaturated. And then we actually have a second double bond, so it tells us there's more than one double bond. And because there's more than one double bond, we're going to call it polyunsaturated. And here's an example. That's linoleic acid is one example of those. And there's a number of different types of fatty acids that are out there. Now you can have a look at this in your book where it talks about good versus bad saturated versus unsaturated. And I'll leave that up to you to have a look at, or what trans fats are. Now let's go here and start to look at triglycerides. Okay, now triglycerides are interesting because we have two components to them. We have to make a here's a triglyceride that's being made, and you notice we're going to have two components to it. Okay, and how do we make it? Well, we start off with a glycerol, and a glycerol is this carbon backbone. And you can see the carbon backbone has a hydroxyl or an OH group here. And not surprisingly, through dehydration synthesis, I can pull off a hydrogen here, an OH here, and I can add these to there. Okay, so what am I doing? I am starting off with a glycerol molecule, and then I'm adding fatty acids. And because there's 1, 2, 3 spots where I can add a fatty acid, and you can see down here I have added 3 fatty acids, it's a triglyceride, tri for 3, right? And of course this was accomplished by dehydration synthesis. Now, as we saw previously, there's different types of fatty acids, right? There's different fatty acids that can go here because there's not just one type of fatty acid. So the triglycerides, 3 fatty acids linked by dehydration synthesis to a modified glycerol, which is a 3-carbon structure, and it's a storage polymer for fatty acids, sometimes called neutral fats. Now, let's have a look at some more. This is the world of phospholipids, and the name tells you a lot, is that we have a lipid and we also have a phosphate group that is attached. So what we have here is our glycerol backbone, and we have 2 fatty acid tails attached and 1 phosphate head. So we're starting from that basic glycerol backbone, but instead of just plugging in 3 fatty acids, I'm going to do something different. I'm going to plug in 1 fatty acid, a 2nd fatty acid, and if this was a triglyceride, there'd be a 3rd fatty acid, but we don't have that. Instead, what we're going to do is we're going to attach this group, which is a phosphate group. And this is what gives us the phospholipids. And often they're diagrammed like this. You can see that here's the head. The head would be this combination. And these tails that they show are basically the fatty acids that we plugged in. And we'll see this when we talk about cell membranes. Often they draw cell membranes. When they draw them up close, they show you the phospholipids with the heads and the tails. Now, the really big thing to know about these phospholipids is that we have the phosphate group is polar, and then we have the non-polar fatty acid tails. So we end up with this compound that is partly polar and partly non-polar, and we call that amphiphilic. Now, why is this important? We're going to see this has to do with whether the part of the molecule is hydrophilic or hydrophobic. Does it like to be in water or not? Doesn't want to be in water. And we'll get into that discussion when we start talking about cell membranes. So these are very unique things with this amphiphilic nature right here. Okay, and you can see it, if we were to do one of these space-filling models, you can really sort of see that the diagram here is that would be the glycerol part. We plugged in 2 of the fatty acids here, and here we plugged in basically the phosphate group as part of the head here. Now, also when we're dealing with lipids, there's other categories. We have the steroids, which are nonpolar, and they're 4-ring hydrocarbon structures. And you can see that they all they're all based on this one structure where there's, as I said, 1, 2, 3, 4 of these rings. And in some ways, all we're doing is adding different functional groups to them. We're pulling off bits, we're adding new bits. And that can actually change the basic structure quite a bit. So when we're looking at steroids, we're looking at nonpolar 4 hydrocarbon rings, and that we can call the steroid nucleus. And then you notice what we do is we just start to add little functional groups to it. Maybe we put in a double bond here, whatever. And by modifying this basic structure, I can get quite diverse molecules, or compounds I should say, like testosterone. It comes from this. Cholesterol comes from this. And the list goes on of things that can be made from this steroid nucleus. And we'll see many of these as we go through the course. All right, so I'm going to end it there. The next section will be on proteins, and so the next video I'll pick it up and talk about proteins, what they're made of, and also their organization, how they go primary, secondary, tertiary, quaternary, and a little bit about what they do.